Okay, now we get to do sums of a geometric sequence, which is equally as fun, if not more fun, let's be honest. The formula for finding the sum of a geometric sequence, we are going to use a sub 1, it really doesn't want us to do this, does it? Good news, I fixed it. A sub 1 times 1 minus r, wow, r. You guys, I'm about to lose my mind. R to the n. Oh, now I've forgotten it. There we go. Over 1 minus r. Oh my goodness, you guys. We're going to survive this. Okay, a sub 1 times 1 minus r to the n over 1 minus r. Okay, keeping in mind as well that r is equal to a sub 2 divided by a sub 1. Okay, we're going to have to find all this information, list it out for each problem, and then you're going to plug it in to your answer. So, number 9. Here we go. We're going to switch back to purple because that one seemed to have better luck for me. Remembering to find your n is the number of terms. If it goes from 1 to something, you can use the top number. Otherwise, you're going to subtract the numbers, then subtract again. We'll look at that on the next one. So our n here is 10. N equals 10. Okay, our a sub 1 is the first k value we plug in. So a sub 1 we're going to find by plugging, here we go. Here's my laser. We're going to plug 1 in for k because that's my first term is whatever down here it tells me my k value is. That's always my first term. So this is 10 to the 2 minus 1, which is 10 to the first power, which is just 10. A sub 2, which we have to find in order to find our r value. Our second term, we're going from 1 to 10, so our second term would be a 2, would be 10 to the 2 minus 2. That's a minus, pretend like that's a minus 2, which is 10 to the 0 power, which is 1. Now that we know a sub 1 and a sub 2, we can calculate our common ratio, our r value. So we're going to do 2 divided by 1. So 1 divided by 10. A sub 2 divided by a sub 1, which would give me an r value of 1/10. You can see how fun this is going to be. So now we have my a1, we have my r, we have my n. We are ready to plug it into our formula. We're going to risk it with green, you guys. Okay, so in our formula, we're going to start with 10. Parenthesis 1 minus r, which is 1/10. I'm going to use 0.1 here just because, oh, look, fancy zooming. Not what I was trying to do. Because 0.1 is an easy decimal to write. It doesn't have any repetition or crazy things going on. To the 10th power, all of that over 1 minus r, which is 1/10, or 0.1. Again, I'm writing it in both ways just so you can see the values there. But again, only write a decimal if you're not really rounding it. 0.1 to the 10th power is 0.01. So 1 minus 0.1 is 0.999999. So on top we've got 10 times 0.9999999. You get the gist. All over 1 minus 1/10 is, or 1 minus 0.1 is 0.9. So then you can type this into your calculator. 10 times 0.9999 is 9.99999 divided by 0.9. You end up with an answer. These are all going to be approximately of 11.11. That one is nice. Actually, the next two give you pretty easy answers. So kind of go in. What I would do right now is I would pause the video, go ahead and do number 10 on your own. See how it goes. It still has an n value of 5. It just goes from 1 to 5. So your n value is going to be 5. Find your a sub 1. Find your a sub 2. Calculate your r. Plug it into your formula and then get an answer. You get a beautiful integer answer. So pause. Push the pause. And then don't be confused with an 11 there. Push the pause button. Try it and then see what you get as an answer. And I'll tell you what the answer is in just a minute. So pause. Okay, now that you've pushed play, after you've done the problem, you should have arrived at an answer of positive 31. If you did not get that, then look in the back of the book and find where you went wrong. But for the sake of time, I'm going to skip that one. Okay, number 11. Here we notice some things. We're going to start with a k value of 2, so we're going to have to be careful with our n value. Since we start at 2 and go to 11, we can't just use 11. We only are going up by 10. Okay, so basically you do the top minus the bottom and then add 1. So 11 minus 2 is 9 plus 1 is 10. So our n value is going to be 10. N equals 10. We're going to find our first a value, a sub 1. We're going to have negative 1 to the k plus 2. So our first k value is 2. 2 plus 2. Negative 1 to the 4th power is just positive 1. A sub 2, negative 1. The second term would be 3. So we've got 3 plus 2, which would be 5. Negative 1 to the 5th power is negative 1. When you take a negative to an odd exponent, your answer is negative. When you take a negative number to an even exponent, your answer is positive because of your negative pairing up. That means your R value is going to be negative 1 divided by 1, which is negative 1. Okay, now we're ready to plug it into the good old formula. Our formula tells us to do a sub 1, which is 1, times 1 minus r to the n. Our r is negative 1 to the n power, which is 10, all over, I literally just forgot, 1 minus r, just kidding. 1 minus r, which is negative 1. We've got a party of negatives happening here, so be real careful as you do this. Okay, so 1 times negative 1 to the 10th power is positive 1. 1 minus positive 1 is 0, so we're going to have a 0 up here. At this point, you should be able to predict your final answer, but we'll work through it just for kicks, just to watch the negatives. On the bottom, we've got 1 minus negative 1. 1 minus negative 1 is 1 plus 1, which is 2. But 1 times 0 divided by 2 is just plain 0. So your answer here is 0. Okay, hopefully that feels all right. Just watching your signs, being real careful there. Number 12 is a crazy doozy of fraction mayhem. So I'm going to do my best to write it on here. But if you get lost in the actual numbers I write, feel free to just kind of check back at the back of the book. The process is what I'm looking for. And then you're just going to have to be really careful in your fractions and your math and trying to avoid decimals just to keep your answers happy. Okay, so, oh, that's actually not a bad idea. Let's go sideways and see what happens. It might give us more space. Okay, first thing I'm going to do is figure out our n. We're going from negative 2 to 1. So if we do 1 minus negative 2, that would give us 3, because 1 minus negative 2 is 1 plus 2. And then we add 1, which would be 4. So my n is 4. You can also think through, I start at negative 2, then negative 1, then 0, then 1. That is 1, 2, 3, 4 terms. Okay, there's another way you can just count them in your head if you don't trust the weird top minus bottom plus 1 formula. Okay, that's an eraser. A sub 1. We're plugging in negative 2 first. We've got 1/4 to the 2 times negative 2. So this would be 1/4 to the negative 4. If you remember, negative exponents flip my fraction and become positive. So 1/4 to the negative 4 is the same thing as 4. I've taken my fraction and flipped it over to the positive 4. Okay, to see that real kind of quickly out to the side, 1/4 to the negative 4 is the same as 1 to the negative 4. That's really hard to read. Hold on, let me get it darker. 1 to the negative 4th over 4 to the negative 4th. Anywhere you have a negative exponent, you can move that whole thing down. So 1 to the negative 4th is 1 to the positive 4th on the bottom. 4 to the negative 4 on bottom is 4 to the positive 4 on top. 1 to the 4th is just 1, so we're just going to ignore that. That's where we get our 4 to the 4th power. Okay, which is 256. My palm recognition is really recognizing my palm today as my finger or as my pen. Okay, now a sub 2. A sub 2. We've got 1/4 to the 2 times my next term. It goes from -2 to -1. So -1. Whoa, it made an I. Totally weird. This is 1/4. 2 times -1 would be -2. By the same properties, this is the same thing as 4 to the positive 2, which is 16. My R is going to be 16 divided by 256, which reduces to 1/16. There we go. Lots of things, all divisible by 4. So just know they're built on the same number. So there's going to be some reducing that happens along the way. So plugging this into our formula, we've got a sub 1, which is 256 times 1 minus r to the n. So this would be 1 minus 1/16 to the 4th power all over 1 minus r. So minus 1/16. 1/16. Just know that says 1/16. Okay, reducing this down, kind of simplifying where we can. On the bottom, 1 minus 1/16 would be 15/16. Okay, on the top, we've got 256 on the outside. We've got 1 minus 1/16 to the 4th power, which is 6, and use a calculator for this, please. 65536. So that's a 65536. 1 minus one of those. So if you think about 1 can be rewritten, this one right here, can be rewritten as 65,536 over 65,536. So then my numerator would be 65,536 minus 1, which would give me 65,535 over my common denominator, which is 65,536. That's now the inside of my fraction. The outside is 256. Because 65,536 was built on multiplying by 16s, they're all have common factors. If you divide 65,536 divided by 256, that goes to 1. 65,536 divided by 256 leaves you with 256. Okay, so that's actually 256 squared is what the 65,000 number is. Okay, so all this mess up on top, it is all reduced down to, on the top we have 65,535 over 256. That is what's left on the top. On the bottom, we have 15/16. If we are dividing by 15/16, that's the same thing as multiplying by 16/15. We're going to do some good reducing here. 16 divides to 1. 256 divided by 16 is 16. Lucky for us, we see things end in 5, and these buddies ending in 535 and 15 will reduce. They both divide by 15, so that goes to 1. That was already at a 1. 65,535 divided by 15 is 4,369. All I did was divide by 15. So if you look here, the 16 divided out to 1, the 15 divided out to 1, these have reduced to 4,369 over 16, which is what our final answer is going to be. I'm going to write it right over here. oops, let's write it in blue. It is 4,369 over 16 would be your final answer here. Okay, so again, you just have to be careful. Use lots of paper, kind of build yourself up. Make sure you pay attention to where you are. And here it can get messy trying to remember what's on top, what's on bottom. Try and use as much logic as you can, okay? Because here I knew that 1 is just this denominator on top and bottom. If I subtract 1, it's just 1 less over the original denominator I had. Know that these numbers are going to keep reducing, so reduce as much as you can. You're still going to have large numbers, but they're not going to be as terrible as they could be if you're reducing along the way. Again, I would steer clear of using decimals because the numbers are so small and so ugly. If you round it all, your answers are going to be very, very skewed by the time you finish. Okay? From there, that's basically all it works out in along the way. Again, please, please, please feel free to FaceTime me, or let me know before you FaceTime me, but text me or email me and we can set up a time for a FaceTime, or you can just send a picture of what you're stuck with. If you want me to work through a problem, you kind of understand, but you may not, but you don't have time to live chat, then I can just record a screencast like this and just text it to you of any problem or anything like that you have. I am here as much as you can. We just have a couple chapters left. We are scarily close, and we just go back to basic algebra stuff with, basic is air quotes there, with radicals and absolute value. Comes up in 28. 29 is inequalities, so the same idea as what we do in 28, but using greater than and less than. And then 30 is limits, which is your introduction to calculus. So we are near the end. Get your test back to me, get me some grades, and let me know if you have any questions. All right? Hope you guys are having fun. I'm missing your happy pre-cal faces. And yeah, let me know if I can do anything.